we solve problems using data science in these conditions, okay? So what we do? In a sentence, we help production companies to be more productive and profitable through the production and logistic process optimization. Okay, we create value, transforming data in information, knowledge, and finally in actuations. I guess you already heard this many times, but by itself, data, it has no value. We cannot do anything, for example, anything with the LAC raw data, right? We need detector information. We need to link all data and create the tracks. We need to understand how particles behave and decay, even those particles we cannot see. And finally, we need to contextualize our measurements against a theory. For example, what does it mean a particle with 125 GeV and spin 0? Well, we need the theory to contextualize. And in our case, we don't need to know a lot about physics, but a lot about the business we are working on. We try to merge data science with this manufacturing expertise. So what exactly this means, no? In order to explain this, we created a rock, paper, scissors game where you play against a neural network. Well, if you want to play, I can send you here the link, and you can have a look. Well, the idea here, well, I'm going to play one game now and show you. But the idea is to play the game finish after 50 seconds or when one player wins 5 moves. Okay, and so let me show you. You have here the link in the chat. Don't well, the database and the resources are not prepared to work with 20 or 30 people, so be careful, okay? But the idea of this is, as I said, to play against a neural network, right? So we have 15 seconds, and we can click in rock, paper, or scissors. And in principle, this is a random game, right? You can play, click randomly in any of these selections, and so you should have more or less the same probability to win or to lose, right? But in the first game, you see that the algorithm won. So let's play. I can, and the algorithm won again. Okay. So how this translates to this to our business? Okay, we have here this statistics page. Let's see. Sometimes it takes some time to load. Okay. So these are the results of the games played from, I guess, last September of 29. Here, well, are sorted a little bit confusingly. See, you here see 3 of 6. These are the last games. So here you can see all the games with the sequence played. Okay, and you see here in this plot the number of the proportion of won games against to the lost games. You see that the won games by the human are less even than 25% of the games. If these were random, if the play were completely random, you should expect at least around 50%, right? So this game is not random at all. Here you can see also the number of roles played in each game, and you see more or less the same number of roles lost and won. And here in this plot, this scatter plot, the x-axis represents the average velocity played in each game against the number of roles. So in for each game, you have 2 points: one for the number of roles lost, and one for the number of roles won. And in this trend, you see how as the average velocity of clicks increases, the probability of lose a game decreases. So here comes the first recommendation for the player. You should take your time to play. You have 15 seconds, so use the 15 seconds. Okay, and here in these other plots, you have the number of repeated clicks. For example, if you click twice in a rock, is a repeated click, no? So you should have here a number 2. If you click 3, you should have you get the number 3 for the number 4. This is for win part games, and this is for the lost ones. And you see that in the won games, you repeat much less than in the lost ones. So here is again another recommendation. You should repeat the less as possible. You have to take your time and change your play every time. And finally, here in this velocimeter, we have the number of repeated clicks, or not repeated clicks, the different roles each time. Okay, and you see that the average is 4.31 different roles in each game, and the target is at 8. This means that when we pass this number, we hit the 8 different roles in each part in each game. We will have more probability to win the game. So what we do in how we translate this into our business. So we gather the data from the processes as we do it from this game. We sort the data. We create meaningful KPIs. We visualize the information in an easy and understandable way. And finally, we provide recommendations to improve the process. Okay, so this is exactly what we do. Well, why this happens? Why we have a lower probability of winning a game if we click with a bigger velocity? This is because humans are very bad creating random sequences. So well, how if we decrease the velocity, it's more the more random we are creating this click. Okay. Well, we have also this this game. This is the Arrowson Oracle. Maybe you heard about it. And this is more or less the same. This, instead of have a neural network, we have a decision tree. This takes the last 5 movements of the player and try to predict the next one. This is just a fork from this page. And if we move, if we play, well, now I am around, 60%. And this is a typical situation that the algorithm, the Oracle, predicts around 65% of the movement. You can take you can play if you want also. So, oh. Let me again share my screen. Okay, so just to let you know, this is the neural network behind this rock paper scissors play game. As you can see, it has 3 inputs, 3 outputs for rock paper and scissors, and 3 layers: an input layer, output layer, and just one hidden layer. Yeah, it's a very simple multi-layer perceptron. Nothing special. Okay. So, and how we analyze a problem? Okay, so we divide the process in 3 stages, in 3 different stages. We have first the business relation stage. Here, a person must work with the client on identifying the problems, identify the goals, and learn how the business works. For the ones familiarized with the software development world, this figure is very, very similar to the business owner, right? Well, afterwards, the business translator gives the information to the data engineer that create the data models and prepare the data set to be analyzed. Sometimes the process already finished here after creating a business intelligence report. In this moment, the client only needed visibility of the factory. So here we are giving value to the client. And then a data scientist takes over and analyzes the data, create models, and find hidden patterns. We can then just show this information so the managers can take relevant actions, or we can directly send instructions to the PLC to change the production parameters. We have samples of both. And well, the data scientist is the person who really extract real value from data. But the pillar, look at this, the pillar of the process is to identify the problem and understand the business. So even the data scientist is a very important person in this process. We think that the business translator or the business translation stage is the most important stage, because we have to understand very deeply the business and try to find a solution with the client. Okay. And what kind of questions rise from here? For example, we have these are typical questions. What process conditions maximize globally my profit? The companies the first goal of the companies is to earn money. So we have to increase the profit of the company. So this is a very common and transversal question. In what conditions my equipment is better than my competitors? All the companies need to be better than their competitors, no? So this again is a very common question. What should I recommend to my clients for optimum use of my equipment? This is the case, for example, for a company that sells some equipment, no? That finally for the final production companies. What variable combinations, humidity, temperature, thickness, pressure, velocity, are causing mass defects? Sometimes, well, and we have real cases of companies that have some defects in the pieces, but they don't know where they come. They are doing always the same, or they think that they are doing always the same, but the final result is completely different. So with this process, with analyzing all this data, we can understand what's happening here, and how raw material variability and processes affects the final product quality. This is very common in the alimentation, in the food sector, because in the raw material variability is huge. You know, for example, we can buy fish, and the fish, even though it's the same kind of fish, they have very different properties. Fish or pig or any kind of raw material. And how can I detect improvement areas? Okay, this all of them are very typical questions in this industry. So now, after this, I think 7 slides, I'm going to introduce ourselves or the company. So, as Xavier said, I am Pablo here. I'm this one, the upper left corner. And, well, I am a particle physicist, and I am also an engineer. And here below my photo is Antonio Sartal, who is a PhD in organization engineering and has more than 15 years of experience working in R&D in industry. And both we are the founders of Triple Alpha. And from here comes the slogan of merging data science, that is my part, with manufacturing expertise, that is Tonio's part. Okay, and with this we try to grow the company around this sentence or this idea. So here you can see at the top Andrea and Raquel, who are mathematicians with master in statistics, and here Angel and Lorena, who are telecommunication engineers, and Fatima here at the right, that is who is engineering organization, Antonio. And finally, maybe the most important person in the company is Veronica, who is our head of administration, who moves the money. Okay, and so as you probably you already saw this many times, no? The data scientist or a company in data science has to merge these three parts: the expertise in computer science, in math and statistics, and business knowledge. We, as a company, try to move to more or less here. As I told you, we think that the business knowledge here is very important, and it's also very important how to know how to move this data, and not as important the tools that we use to rank to move this data, to work with this data. I say this, but we have also some very strategic projects in computer science. I'll tell you something about it at the end, okay? But we think that we have to understand, well, our goal is to understand business perfectly, and also the maths and statistics. And well, I'm going to tell you now something about data architecture, the data architecture in a factory. Some of you have ever been in a factory and have ever been seeing the data, its data architecture. Okay, Well,
No.
okay, no. Well, maybe you think that is something. Yes.
Sorry, it's a joke, Miguel. Unfortunately, yes.
Yes. Good answer. Yes, some of you could think that is that the companies need a very good architecture and clean and organized to earn money. But at the end, the data architecture in the classic, let's say, data architecture in a factory is something like this. Here at the bottom we have the machine control. Okay, here, for example, one of these circles could be one machine with one human interface, and this machine is autonomous. So you can, for example, could be I don't know, the machine that puts a wheel in a car. Imagine that is a machine what install this in a car. No? And we have a lot of this kind of machines in the factory, and we have other type of controllers and sensors and etc. This information usually, or the classic way of work with this is to access this information directly. Right? If you are the responsible of this machine, maybe you can take this information in an Excel sheet of or similar to that, or even connect directly from another software. Right? Okay, you have in your laptop install a software that connects directly to this machine. But you do that, your partners do the same, and some people in other departments do the same in any other machines. And when you have a meeting with administration, you create a report and you go to that meeting. But the same happens to your partner and to other departments. So you get the meeting and you have different values because you thought that something should be calculated in a way, and you did something different. And so the meeting is focused on how this information can be different. Okay, there's no unique truth. There's a mess. Okay, so this is the classic architecture in a factory, and still happens. Believe me, it still happens in a lot of companies. So, what we want to achieve, or what is the desired architecture? Okay, this pyramid is our factory, and we have the entrance of raw materials and finally the finished product, right? We have some information system. Well, this is the MES system, that is manufacturing execution system, the acronym of manufacturing execution system, and is the system in charge of execute, supervise, and control the factory. Okay, so all the information, or almost all the information of the production lines, comes to this system. Then we can have other information system like LIMS. LIMS is for the lab, and GMAO. GMAO is the acronym of Gestión de Mantenimiento Asistido por Ordenador. Okay, and these are different information systems that we can have in our factory. And finally, the ERP system, that is the enterprise resource planning, that is more focused on business. Okay, this is for the direction of the company, and puts in contact the providers with the factory and the clients. Okay, so as you see, we have the information now more sorted, more clear in different information systems with with specific characteristics. Okay. Once we have these information systems, we want to have this unique truth that I told you, right? We want to merge all this information and put it in only one place, so it can be accessible to anyone in the company. Here we can merge all the information of these information systems, but also we can storage non-structured data, for example, web pages or audios or images, etc., or even Word files or PowerPoints, etc., or semi-structured data that can be results from surveys, from web forms, or anything. And also other information coming from PLCs or IoT devices. This information goes to any other information system, but sometimes can happen that you want to send it directly to this storage, okay? And this storage can be a SQL database, for example, a data warehouse, or a data lake. Well, okay, can be anything of these options. In another way of see this, to see this is more in the flux of the information. Okay, here we have this the information and the factory information systems, and we want to, as we said, we want to storage in this central repository. Okay. Also, these PLCs and IoT devices can go or can be analyzed in a machine. This is the case, for example, as I told you a few minutes ago, for example, that you have a machine that performs a specific task. For example, put the wheel in a car or anything like that. In this case, you can have some machine learning or some functions to analyze the data that is coming in real time and to show directly information to the operator of that machine here in a user interface, or to take some actions directly. Yeah, okay. You can detect that the machine is moving in a dangerous zone, so you can change any parameter, so reduce velocities or increase or anything. Okay, and this central repository can be on premises or can be in the cloud. For example, we try to use always the cloud, and we use Azure, Microsoft Azure. I'm going to talk a little bit about Azure now. I want to explain you some things and why we decided to select Azure. Here in the cloud is very useful because you have a lot of services to work with. You have functions. We can create virtual machines to analyze this data. Virtual machines, even this is Microsoft. You can create Ubuntu, an Ubuntu virtual machine. You can create almost everything. You can work with Office 365, or well, you have a lot of possibilities. And finally, you can show this information in a dedicated web. You can program your web to show the data exactly as the client wants to see it, and also to send back parameters to the factory. Or you can also create a report in Power BI to show the information, to show the KPIs. Okay. Well, here you can see an architecture of data analysis. This was taken from the one page of Microsoft Azure. This is a typical, this is one option when you are analyzing data, big data. Okay. And you see, that you get the data. This is Azure Data Factory is just to gather the data and transform an ETL tool. Okay, the data lake storage just to store the data. Databricks is where you analyze all this data, and finally you storage in this kind of database and show the results in Power BI. Okay, this is a good data architecture for industry, for us, for example. No, because these services are extremely expensive, extremely expensive. So as I said, we don't have too much data, so we can use probably one or two virtual machines and create all of this, or we can create some services, some more cheap services to analyze this data directly. Okay. Now I'm going to define what is cloud computing. Okay, cloud computing is just the on-demand availability of computer system resources, especially for data storage, that is typical when you use, for example, Dropbox, or computing power. Here you can see the four more important, the four biggest vendors of cloud. And as I said, we use Microsoft Azure. Maybe Azure and Amazon are the two biggest, the more accepted vendors, and maybe Amazon is a little bit ahead of Microsoft Azure. But why we decided to choose Azure? This is because in the industry it has much more acceptance, Microsoft, than Amazon. When you go to a factory, they use a PLC, and usually they use Windows for everything. And the PLCs are the programmable logic computers that operate one specific machine. And usually these PLCs have a software that runs under Windows, and the vendor of this PLC sometimes use already Azure. So, well, we decided to move to this ecosystem to be more prone to be more accord in this ecosystem. Okay. Well, and what kind of resources we can buy or we can use in the cloud? Well, there are three different levels. Okay, infrastructure is when you buy directly for example, the block storage, the network, or a virtual machine, for example. The platform, you get a platform as a service. When you get services, specific services like a database or identity services, for example, the domain, the Active Directory of the domains, or anything like that. Okay, and the application is software as a service. When you get, for example, your mail, your Gmail is software as a service, or chats, or finances, or etc. etc. So for a better understanding of this, okay, let's see it as a pizza. Okay, pizza as a service. The typical on-premises, on local, when you do it local, is this situation here at the left, and is when you have your kitchen, you have the oven, you have the pizza, the toppings, etc., and you do all the process. Okay, this is the typical on-premises situation. The infrastructure as a service is when you only ask for the infrastructure. This is the kitchen, the gas, and the oven, and you put the pizza dot, the toppings, and you cook the pizza. Okay. Then, if you want the platform as a service, you ask for the kitchen, the gas, the oven, and the pizza dot, and you only put the toppings and finally cook the pizza. Okay. And finally, software as a service is when you go to a restaurant and you order one piece. Simple as that. Okay. And what are the pros and cons between cloud and local? So for the local, you have a total control of the infrastructure. It is very highly customizable. You can do anything that you want in this in your infrastructure. It has a very low latency, and you have a very high control of your data. This is very important because now from a few years ago, the companies are very concerned about the data. They don't want to lose this control. In the cloud, the pros are that you pay per use exactly as you are using. You have a large computation capacity, is very flexible, very scalable, and easy to configure and deploy. And the cons for local, you have to put a very high initial investment in hardware and software. You need experts to do this all configuration and installation of this hardware and software, and it has a very high maintenance cost and low scalability. Every time you need to escalate or to increase your power, your computation power, you need to buy new devices. And for the cloud, it's difficult to customize. It has very specific software. It has much higher cost on the support, and you have very limited control of the data. You have control of your data, but sometimes you don't know where exactly this data is. Okay, and here, well, specifically for Azure, this is a Wikipedia definition of what is Azure. It's a cloud computer service for building, testing, deploying, and managing applications and services through Microsoft managed data centers, and provides software as a service, as I said, platform as a service and infrastructure as a service, and supports many different programming languages, tools, and frameworks. This is very interesting because you can use almost any language or any tool or any operating system, as I said. For example, here in the services that you can buy, here you see at the top left corner that you can, for example, to launch a data science virtual machine in Windows or in Ubuntu. And this is something that we do very frequently. If you have to use some tool that you have to install in your computer, or and it's difficult to install, these virtual machines already comes with these virtual images already comes with some installed software. So you only have to deploy this machine and start working. And this takes maybe 10 minutes, more or less. And after you finish, you can remove this virtual machine, and you only are charged for this 1 hour, 2 hours, or anything that you were working on. Okay, you have also a lot of databases, different databases. For example, here you can see MySQL, MariaDB, SQL for sure, Postgres, Cosmos, etc., etc. And you have also all services like Azure HD Insight, or let me see, well, Data Factory, or Azure Data Explorer for analyzing this data. You have a huge amount of possibilities to work with. So now we are going to do a small example, okay? So of to analyze some data using this machine learning studio. This is a very simple drag and drop tool that lets you build, test, and deploy predictive analytic solutions. Finally, when you have this the model trained, the application publishes the models as web services. Okay, so we are going to see two examples. one for clustering. I think you already saw this sample many times. This is the one for the iris data, to group the iris data. And the other one is the multi-class text classification using a neural network. Let me, well, I'm going to share you this okay. One moment. Okay, I'm sending you to the chat the information of the two examples. First one is the iris one, and the second one is the text multi-class text classification. And now I'm going to show you the machine learning studio. Okay, just to show you, you should have now an invitation to the machine learning studio in your mails. So please check it and tell me if you don't have that invitation, so we can send you back this invitation. Okay, I'm just going to show you very quickly how this machine learning studio works, right? Okay, so you can do this at any moment if you don't understand how anything works. This is just the tutorial, okay? And you can build an experiment in 5 short steps, okay? So you can click in new experiment, a blank experiment. Okay, so first you change the name, and now you can add the data set. Here, for example, is the adult census income. Okay, you add the data, and you can see all the data that is here. You have 32,000 rows, and here you can see all the columns, and finally here the income. And here you see some histograms with the information summarized. Okay, then you want to split the data set, so you just take this module for splitting. You change the data set you want to split, and you select the model. For example, here is a 2-class boosted decision tree. You take the module to train, you take the part of the data, the split data to train, and here you select which column you want to analyze. That is the income. Once you have your sample trained, you want to use the model to score and evaluate. Okay, so now we run the experiment. Here, clicking on run. Well, it takes some time. This was quick, but it takes maybe a few minutes. And finally, you have the results, score levels, and the probabilities. Okay. And in the evaluation, you can see the raw curve and the results, the confusion matrix. Okay. Okay, so now we are going to see our examples, our own examples, and well, this is the first one. The number one is the one for the group iris for the iris, and the second one is the text classification. Okay, the first one, as you can see, is very simple. Or you put some minutes, a few minutes on understanding this, you see that it's very simple. So here you have, again, you import the data, you clean the missing data, just you remove all the rows containing any missing value. Here you change just the name of the columns, to edit the metadata and change the columns. Split the data, as we saw in the tutorial. Here we are using two different models, a k-means clustering and a multi-class logistic regression. We train the models, and finally, for this one, for the regression, we score the model and we evaluate the model. Okay, clicking here, we can visualize the results. Here we have the confusion matrix. Okay, and on the other hand, we see here the results for the clustering. Okay, how are this graphically, and here we see the results in a table. Okay, and we want to see the confusion matrix, we have to click here and compare with the segments. Okay, so we see here the confusion matrix. Well, 0, 1, and 2 are the names also for the iris setosa, iris virginica, and versicolor. Okay, so try now, if you want, check your mail and try to access the Machine Learning Studio and play a little bit with this example and try to beat these models, the multi-class logistic regression, change the models, or do anything that you consider to be the model. Do you agree? Yes? No? Okay, so in 2-3 minutes, we can go for the next example. So just have a look.
Please don't. Sorry,
yeah.
I didn't find the email.
Okay. Who are you? Adrian. Okay. Lorena, can you send him the mail?
Yes. We use the email you put in the form to join the course. Maybe it's in that one.
I cannot use the chat either, so let me send it to you through another channel.
And if you have problems running your samples, be patient, because we usually use, we never try this workspace with more than 5 people. So now we are much more than 5 people. So, be patient and let's hope that anything crashes. And if you have any question, please ask with your voice or with the chat.
Sorry, Álvaro. What
Yes.
you want us to do in this, you know,
No, just to play a little
to
bit.
play with
Yeah.
with the system and to look
Yeah.
at it.
Yeah,
Okay.
and well, yeah, we have another example more. So in the next one, you can work a little bit more with it. But the idea is to try to use different models and different algorithms and try to beat these ones.
Okay. In fact, it's very nice and very clean, this thing.
I have a question concerning the import data, because it seems that some info is required to upload the data. Maybe I missed some part of your explanation.
Some info for what?
For import data.
Yes. I don't understand the question. You mean in the sample? You mean the information that is on the right? Or
On the top of all these share
yeah.
scheme.
Well, let me share. Okay. Yes. Import data. Yeah. But what exactly is the question?
That I don't know where is that data, or
Yeah.
Mhm.
Yeah. You take this from here. You see samples, and here you have all these samples.
Okay.
You just have to drag and drop this the sample and put it just directly here.
Okay, thank you.
Simple as that. Okay, so how do you feel with this tool?
So I think it's convenient, but at the same time, one of the main drawbacks of machine learning algorithm is the feeling of black box, right?
Yeah.
But here the feeling of black box intensifies a lot.
Yeah, absolutely. Yeah.
So,
Yeah.
but no, it's very. I understand that for in some cases it's very convenient and very handy to have it in this way. But
yeah, here you have you can also use Python scripts. Yeah, if you don't want well an algorithm of this, you can create your own algorithm, your Python script. Okay.
yeah, that's nice.
Yeah.
But I would say conceptually is very neat. You know, it split the task clearly in the things that you want to do. So it's certainly clean. It helps to understand the flow and the process quite a lot.
Yeah. Yeah, it is very easy to understand how the flow of the process is. But as Xavier said, sometimes you see a box and you think, okay, what's happening there? Okay, let's move on to the next exercise, because it's more or less the same. It's a little bit more complicated, but okay. You see, in this case, well, you have some more steps, and you use here a neural network. Okay, but here I'm not going to tell you anything, so try to understand what's happening here. In some places, well, in the preprocessed text, you clean the data. So this is for the sentiment, no? To classify the sentiment if it's not nice, or very nice, and so you can see, try to see where we clean, or the example cleans the data. Then, well, it splits the data to parallelize the computation. Finally, well, it merged the data again and use again two different models. Okay, and finally it has a model evaluation. So try it. Try to understand a little bit. Okay, and if you want, try to use different models again, different algorithm to beat the results. You can change something here in the neural network. Okay, these are some parameters of the neural network, or this multi-class decision jungle. Yeah, but more important, I think, is to understand how it is cleaning the data, and what are the processes to finally get the result. Okay, I think it's not very complicated, because this schema lets you know exactly what's happening, or how is the flow. But well, if you have any doubt, just tell me. And if you beat the result, tell me also. Okay. Has anyone tried to change any parameter on the neural network? No.
Sorry, Álvaro.
Yeah.
How you execute the neural network? That's what I am missing. Oh.
Just here, clicking on run.
In the bottom part. Okay.
Yes. Or you can click with the right button of the mouse and well, I cannot see. Run selected. That as it was already run, it is well. It gives you not the possibility. Okay, but it's here. The run. Well, okay, here in the evaluation, you can see the results for the neural network and for the decision jungle. And as you can see, the results for the neural network are much better than for the other one. Yeah, you can compare the two results. Okay, so if no one has anything to say, I don't know, any question or any comment or anything, we can move ahead because I have some slides for finish. Any comment? Okay, let's move on. Okay, so, well, here we use some techniques and algorithms in this machine learning studio, but as I said, we don't use too much these machine learning techniques. Our main tool is the mathematical analysis, by far. We use statistics, probability, and analysis a lot. This is our main tool by very far, way far. And sometimes, yes, we use machine learning. We try to factorize all processes in an industry or in a factory. And some of these processes, yes, they have the possibility of use machine learning. And in this place, in this moment, we use some algorithms for that. And which kind of algorithms? Here you can see this cheat sheet. For sure, you saw many of these. So depending on the case, we use one of other different algorithms. And exactly for neural networks, no. Probably we use neural network less than 1% or maybe much less than 1% of the cases. Why we don't use neural networks? Because of two disadvantages. First, the unexplained behavior of the network. We need to give to the client, to the factory, an explanation of what's happening and why it's happening. It's not just a question of, well, this piece is going to fail. Okay, yes, but why? I cannot wait until the next time it will fail and remove just remove the piece. I want to fix this problem. So we have to understand what's happening. So, well, the neural networks, as you know, it's difficult to know that. And also it's difficult to determine the exact structures for a neural network. We have very huge different cases. So we would need very huge schemas of structures for neural networks, and it's difficult. It takes time to design these neural networks. So at the end, we take some predefined neural network when we know that a neural network works for a specific case, but in other cases, we don't usually use them. Okay, so now I'm going to talk you about a real case that we are working on, that is the smart curing. That is a project for study ham curing systems based on new sensor technologies and predictive models. Okay, this project was is in two stages. Okay, at the first stage we had the idea of the smart curing of we want to know, to predict the quality of a ham, of a jamón curado, just exactly at the moment as a pig enters in the factory. Okay, knowing its properties, maybe we could predict the final quality. So we presented this to a business, to the BF Food, that is a business accelerator for startups, and we were selected as one of the 5 finalists, and we had the opportunity to work with Torre de Núñez, and this led us to mature our idea, to get a deep understanding of the process, and also got the first data to analyze. Okay, and of course this process was only for 6-7 months, so we had no time to finish this project. So now we presented this project to a CEDETI. CEDETI is the Centro para el Desarrollo Tecnológico Industrial, is dependent of the Ministry of Science, and it shares, or it moves all the money for R&D in industry in Spain. Okay, so we presented this project to this organism, and well, first we went to Badajoz and to talk with Señoría de Montaner, that is a company that produces jamón de bellota, jamón ibérico de bellota, very expensive jamones. More or less are 500 euros per piece, and we were very interested in the project, and they talked also to Grupo Alejandro Miguel, that they produce all different kind of jamones, more jamones of cerdo blanco with duroc, and they, for example, are providers of Torre de Núñez. They sell jamones or ham without curing to Torre de Núñez. And the 3 of us created this project and sent it to the CEDETI. And it was recently approved, so now we are working on this idea, on predict the final quality of the hams, just exactly as the moment of the ham entering the factory. Okay, and first, how following the flow that I showed you at the beginning of the talk, first we have to identify the problem. Okay, and looking at the media, we can see that, for example, a large part of the hams is sold on on Christmas. Here, for example, you see that this 50% of the jamones 5J is sold on Christmas. So we have to predict how our hams will be on Christmas. This is one of the problems. Also, we have the quality, the flavor, the smell, and the color of the hams. We have to achieve a best quality, a best flavor and smell for the qualities. And also, and maybe the more important, we have to we cannot have too much salt on the ham. Usually, when a client, when some of us try a ham, if it's salt, it reject it. So, and it never buy again one of this ham. Maybe, well, maybe not. Around 60% of the complaints come from this from salt, from the problems with the salt. Okay, so we move to the factory and to operations. What are actually exactly the questions for operations and for the factory? So following these appreciations that we had at the first stage, we have to know what raw material produces the best quality. We only want to buy those pieces that let me to produce best or higher quality. What kind of product will be ready to sell at a certain moment? This certain moment will be Christmas. Once the ham is processing in the factory, at the end, I don't want that my ham will be ready in February. I want it in December, exactly. And if it's not ready, what is exactly the quality in December? Can I sell it anyway? Okay, what is the maximum quality I can obtain for each raw material? And exactly for factory, how long should I stay each piece in each stage to optimize quality? What are the most critical variables in the process? For example, here, one of the critical variables will be the salt, but there are much more. And what is the optimum drying curve on each stage? As you know, the process of the curing ham is just to dry the ham step by step with different humidities and temperatures. So what is the optimum curve to achieve this better quality? Okay, so now we move to understand the process flow diagram. This is the real diagram, so sorry I cannot show you, this is confidential, but is the real diagram of the factory. And just to let you know very briefly what is the scheme, you have a reception stage when you receive the pieces. You have the quartering when you prepare it. The salt is sometime when you have a number of days that you have the ham immersed in salt. Then the dry, and finally a seller. For the time span for this for jamón ibérico de bellota is around 3 years, and for cerdo blanco is, for example, the other kind of ham is around 14 months, more or less. Is more or less the half of the jamón ibérico. Okay, once we have the process flow diagram, we create the model data and the data model, and then we go to the processing modeling. Yeah, okay, so we have all variables of at the reception. We know the kind of pig, how long it walk every day for in his entire life, the weight, the farmer, the area that he had to eat, the quality of the bellota and other elements, and then it moves to quartering, and we have to know here the temperature, the the skin thickness, the pH, well, a lot of variables. Then in salt, we have to know, it's very important, the time spent in this stage, and also the temperature and the humidity. Also in dry, the time, the humidity, and the temperature are very important, and finally in cellar also the same. But there are much more variables to take care. Okay, and finally we train the model, and we get this, something like this, that is a report where we show the final results, okay, of our algorithm. Here in blue, you have, well, this is a report for the salt chamber, and here in blue you have the information about the pieces at this moment currently in the chamber. In this gray color, you have the historical data, how it compares with the all historical pieces, and in orange you have the recommendations. Okay, for example, the number of days recommended in this stage. For example, for these hams are 11 days. One already was 11 days, and the other 7. So this one is recommended to move to the next stage. In the next stage, that is dry, it should be both 505 days. And finally, in cellar, for one is 662 days, and the other one 322. And the maximum texture that we'll achieve at the end, well, texture is a measurement of the quality. If you move now the ham, you will have 4.55 for the first one, and the second one, as it is recommended to be 4 days more, the quality of this texture will be only 2.84. Okay, and the maximum quality that you can achieve is this one here for each case. Okay. So, and finally, to finish, just to show you, well, as Tonio and I are PhD both, we are very committed to R&D. We think that is needed, very needed or very interesting for any company to do any kind of R&D projects. And we have I think a lot of them. We have a very new company. We have only 2 years old. We are only 2 years old, and we were on this Business Factory Food, the business accelerator platform. We created this Alpha Cloud platform where applied to this ham idea, and we are also in 3 different, 2 different SEDETI projects where we are just a contractor in this project, one in the automotive sector and the other one for the food sector. And here you can see that we are also in again as a contractor in a European project in Horizon 2020. And this is our SEDETI that I already told you about, the smart cooning. And finally, we are in a project with the IGFAE of Doctorados Industriales that we have the first industrial PhD in the USC, and Lorena, that is also connected, is the PhD student. And that's it. Thank you for your attention.
Thanks a lot, Alan. This was very interesting and very useful, I think. It is very well aligned in mind, so thanks. So, questions for Alvaro? I have a quick thing myself. Well, 2 maybe. One is that you mentioned that you have Amazon or Azure as the standard platforms for cloud computing. So which was the reason for you to choose Azure instead of AWS, for example?
Yeah, the idea was, well, maybe in cost, they are more or less the same. In technology, maybe, as I said, Amazon is a little bit ahead of Azure. But at the end, in the industry, in the factories, is more implanted. I don't know exactly the word in English. The Azure, the Microsoft ecosystem. So and there are much more companies working with Azure in industry than with AWS. So at the end, even that you can use AWS from Azure and vice versa, you can create a much more convenient ecosystem using only one of them. And we decided to choose Azure because of that. And also we have some clients already working with Azure. We have one client that I cannot say the name, but it's a very huge logistic operator here in the northwest of Spain. And they were thinking also if to choose between AWS or Azure. And at the end, they move as well to Microsoft Azure. But the reason was not exactly the same as us, but they thought that these problems or these advantages were important. But Amazon also works in logistic, so they didn't want to have the enemy in house.
Okay, I see. And the other question, I think I asked this to you privately already, but when I think about this, when I try to do parallelism between what you do and what we do in academia, as you said during the talk, the main issue for you is having access to data. In academia, well, specifically at the LHC, we've got more data that we can process. Then there are other experiments that, they're, for instance, single measurement experiments, but still they have data. But one big difference that I see independently from the data itself is the fact that we rely a lot on simulation, right? We have very powerful simulation techniques that really make our lives, or without them we wouldn't be able to do anything essentially. And for machine learning stuff, this is crucial as well. So I was wondering, why there's no more R&D in simulation for this kind of industrialized. Or maybe this is my ignorance speaking, but I had a feeling that there's no a lot of simulation studies or use of simulation in this part of industry. What do you think?
Yeah, well, there's R&D, and I think as the time evolves, I think there are much more R&D in simulation, and I think specifically in very expensive tasks, there are a huge effort on this. And maybe you heard about the digital twins. Do you heard?
No, I haven't.
No. Okay, this is just to reproduce exactly the physical environment in a digital environment. Okay, so you can change anything in this digital twin and test or simulate anything you want. And the steps are going to this scenario, but in almost any cases, or for the real companies or the real factories, what you have is that you have very limited resources. You have the exact number of people to produce the exact number of pieces that you have to sell. You don't have much more than that. And so day to day you have to produce. You don't have very much time to simulate or to analyze and to do R&D. Even the R&D in the industry is very focused on production. Okay, it's not the same R&D that we do in the LAC. Well, we do. There's a lot of companies very focused or very interested in R&D, but well, it's not the same. It's not the same. It's more applied R&D. And so simulation, yes, you have. We are moving in this direction, but each company has a very different. The very different situations, very different machinery and processes. So each company needs to gather its own data and simulate and create its digital twin. You cannot sell a digital twin or a simulation for a company, a generic simulation software for a company. You have to create it with them. And well, this requires a lot of time, and usually you don't have time in the industry. But yes, there are the final the final of the way is that one exactly. Yeah. But these are the problems.
Okay. Yeah. Thank you. So other questions for Álvaro?
Hi, can you hear me?
Yep.
Miguel. Yes, I have a question myself. How easy is to implement in this kind of distributed computing in Apple or Google or Amazon? Because, you know, at LSU, for example, I know that there has been a lot of discussion about this, but no one really explained it to me. How is it to implement these kind of things like 30 MFS, or if you have these software packages that are huge and that take maybe 1 hour or 2 hours to install? How easy to use them inside this kind of thing?
Well, I didn't understand very well. Can you repeat, or Xavier, did you understand?
No, I didn't.
Oh, sorry.
Maybe we can write it in the chat, Miguel.
Yes,
You
the
sound
sound
very-
is.
But you didn't understand the question, or is because there is noise?
I think now is better. Try now.
Okay. So the point is, you know that in LCB you have, or also CMS, Atlas, you have software packages that are really huge. And if you want to use these kind of things like Apple or Amazon, you need to have them in the computer, in the remote computer, so you can run jobs there. So my question is, how easy is to find to implement these kind of things, these software packages, and run for large experiment jobs in these machines?
Well, I'm not sure I did understood. I think that you say that if it is possible to run this the LEC software on Azure or Amazon, right?
Yeah.
Yeah. Okay. Well, I think I'm not qualified to answer that question. I'm not an expert on both sides, but well, I think that should be possible because there are some competitions in Kaggle or any others that give you the data, the LEC data, and you can try to discover the Higgs particle or any other particle. So I think that is quite easy, or at least quite possible to do that. But I don't know exactly the problems that you should have. In any case, well, these tools are expensive. Maybe the grid is much cheaper than use it in Amazon or Azure. Sometimes people think that these cloud services are cheaper than have on premises the systems, but the truth is that when you have resources that you don't use, yes, that is the truth. But when you have completely 100% every time, every day using these machines is not. You should buy your own equipment and run your own software.
I guess that you pay for the resources that you consume, right? Or you pay to get access to 3 machines 24/7.
I haven't understood again. Sorry.
I mean, you pay for when you sign a contract with them, Google or Amazon. What do they offer? They offer you resources, so like you can use 4 computers 24/7, or it's just you pay for what you need. So you log in.
Yeah, usually you pay for exactly what you need. You can create a virtual machine, and if you shut down this machine, you don't pay for the time that this virtual machine was shut down. Okay, you only, if you were working with it for 4 hours, you will pay only for these 4 hours. So this is very elastic or scalable. No? You can work only the time you need it, or you can create these machines only the time you need it. So yeah, if you need to work 24/7, these machines at the end is more effective or more profit to buy your own machines.
This one is more related with the previous question. So imagine that you need to install your own software the same. So you first need to boot the machine, this virtual machine, install the software, and then execute it. Or you can somehow have everything previously installed in the machine. And
no, you can install whatever you want in these machines, and you can shut down the machine, and the next day start it again, and you will have this software. Yeah, you can do whatever you want with these machines. Are virtual machines exactly as you have in your computer, your laptop. Yeah, exactly the same.
Okay, thanks.
The talk is, I'm gonna scroll down like that. You see properly these things? Yeah?
Yeah, perfectly.
So the name of the talk is a bit of a bit too big, say to a neural network business perspective. I don't know if I'm the right person to give business perspective to anybody, but I'm gonna try, and I'm gonna give my perspective. That's for sure. So I'm not the right person to really give you a review of what's going on or coaching you about business. But since today is the last day, and I know that you had a lot of tutorials and things, I wanted to be a little bit mild on the just showing examples, not going into neural nets and things in deepness, but just showing where you can use them and how you approach the problem. Because to me, a valuable information is which are the problems and how do you approach that, and that depends on who you are basically, because it's a totally different question if you are a big company, a small company, or I don't know, industry or retail. So it's totally different things. Albert talked a little bit about the data and the data you have in industry, but and you ask actually, Xavi, that sometimes you don't have data. That's true, but it's not always the case. So if you are in retail, you have tons of data. You have much more data probably than in physics. Okay, you are dealing with data from how is buying whatever thing in I don't know, in the Inditex universe. Probably you have more data than in particle physics. So there's different worlds here on how do you approach your problems in business. Say. So the summary is like really short. I'm gonna do a really short introduction of who we are in Artrobotech, and then that very, very limited by myself of what I know and my colleagues and people I know of my vision of the business world. And I'm gonna throw some examples here and there of things we do and things that I ask around to friends of what are you doing, where are you using neural nets and these kind of things. So first of all, who we are? We are Artebrotec. We are a company based in Ferrol, so 100 kilometers from Santiago by the sea. And I was super lazy, and I just translate. This is a kind of marketing slide we have in the company, and I just translate the title and not the rest, because I don't want to go through this marketing thing like okay, you put value in the data and all this kind of thing. So what we do is we help others. Say we are a provider of technology or tools you want. We solve problems to other companies. It's like what we call consulting. So we help others to overcome technological barriers. So and how we do that? So usually starting with data. So there's many sources of data, and you can use to optimize some process, but also to make decisions. So something like we call business intelligence, and our business actually is kind of drifting to this part of the business, and this business intelligence because because it's what it is. Where you need customers, and we are finding like our place in there, because it's easy. Let's put it in this way: it's easier sometimes to sell stuff to the scissors, so people that have the ability to make decisions, so people on high level in companies, than that getting money for optimization of a process itself, because this is pretty complicated. But a guy say, okay, you're gonna buy a new iPhone. Yeah, okay, it's for me, so I'm buying. You say, okay, you're gonna put a new machine and then do this and then do that, and it's too complicated. So when you offer business intelligence, you are offering something for the guy that is making the decisions. Like I'm gonna give you data and stuff to really make decisions. So you're buying for yourself. So it's easy to sell it at some level, and that's why the market is giving us this drift to business intelligence. So in general, what we do is that it's taking data, even if it's in-house data, it's just data from everywhere, data you can have in public data, you have data you pay for. There are companies that specialize on selling you data with some specific information, or data you have from your clients or yourself or your processes. And the end of the day, the goal of all of this is just put in some valuable way all this data to, again, make a decision or to optimize whatever process you have in your company. So how we do that? This is really simple. It doesn't matter if it's a process, an industrial thing, a manufacturing, or if it's a decision-making thing. At the end, it's always the same. It's like and you are really familiar with this thing, right? It's just data acquisition, and then, as I said, it doesn't matter if it's in-house. You can take data from PLCs, as Alvaro said, or you can sensor even machines. You can put some sensor and then take some data that it wasn't there, but you have to read it. Or you have external sources. And as I said, you can get a lot of information from public sources, a lot of information that you can pay for. And just you mix all these things, you process this data cleaning, and all these things that we are used to in high energy physics as well. And at the end, you do the thing you want to do is some kind of modeling. It's cool to say that we're doing artificial intelligence, machine learning, or whatever, but as Alvaro said, most of the times you don't even need that. So like you do a model, if the model is straightforward, you can put it, it's just some math in there, and that's it. So, and at the end, what we sell is something that is web-based. People access through a web to something that is located in the cloud, and we work with Google Cloud Platform. With some discussion there, why one of the others. Okay, in our case, I'm answering straight these things. In our case, was my partner Alex he was engineer at Google for 8 years at Zurich, so we have no choice. I mean, we just go with with Google, and that's it. So it is a small summary of what we do. So we have a part of the business that is industry, as Triple Alpha is, and Alvaro said already something like it's really in the a la mode or trendy, that is the digital twins. I'm going to explain something a little bit after, sorry. And then we do this kind of specific optimization of parts of the process, or this whole thing that it would be a digital twin. And then we have something that we call data analytics. And there they have several things. One of them, the first one, is a product. So we sell stuff for other companies in the sense that we do a specific work, but we do have something that is what we call a SaaS, a software as a service. that is Artable Tender. This thing is just, it's a software, you pay for it, you pay every year, and that's it. So I'm gonna go through this as well, because it's a little bit different if you do something for somebody, or you do a development for your own product. And there you have room for more improvements because it's something you are developing all the time. While if you are doing a kind of work that is specific and is finishing in time, you're gonna do this. The guy pay for that, and that's it. He can obviously he could come back to the same thing, paying more, and you do another piece of work. But if you have a product, you have to develop it all the time, so non-stop, continuously. So in there you can think of how to introduce this kind of intelligence here and there, because it's your own thing, it's your own development. And well, as I said, we do things like business intelligence. I'm gonna through some examples because it's a really huge field. This thing is saying nothing basically. I would say that it's, as I said before, something like helping people with data to make decisions. So it's just put together all the information to really do the right decision. We do things like technology watch. Is more like it's similar to business intelligence, but it's really what is trending in the market, or how you follow patents or papers, or what this company is doing. These kind of things, like some technology, you can watch this technology and say if it's important to me, and then suddenly my another company that's in my sector is doing this kind of patents and papers, and it's not at the core business. Why? So that you put alerts and say, okay, these guys are going in this direction and not in this other one. So it's just watch what's going on around. And then there's something that is really not appealing, documentary management, but actually is one of the things that is the initiation of more sophisticated things. We're doing things for companies that's basically, they usually have every 3 months, 6 months, the big companies, they have this a review of what's going on in the market, what they're doing, and what the other companies in the sector are doing. And usually this thing is something doing by hand, that somebody just take the information here and there and produce this document. And this document is always the same. So we're doing a lot of work on doing these things automatically. And it's just, taking information from sources and also extracting information from places where you have breathing information. And this how it links with the next step, that is the natural language processing. That is, I have some things after in the talk, and you're gonna see that it's really something trendy now, this natural language process. Okay, and just as an example, because as Alvaro said, is sometimes we cannot say the name of the clients and what we're doing because of confidential things. But in this case, since it was a marketing thing, so like we won last year an innovation prize with Sacyr. Sacyr is a Spanish construction company, a really huge one, and doing this kind of, I don't know, from a bridge to a hospital to a whatever power plant for oil and gas things, almost everything around the world. So they put some, some problems they have in the market to startups to solve them, and there was a competition in several different business lines, and actually we won the whole thing last year. And since they have, they have to do marketing with this thing, we have some. This is the real copy paste of what they put in for marketing. So I can tell you what is written there. So what is this about? What kind of things are we doing here? So a construction company, they have to construct, right? By definition, they have to do something. They have to construct a building, a hospital, or whatever. Or even they're doing industrial things, they have to do an oil and gas plant or a water purifying thing in the middle of nowhere. So to do that, you have to be aware that this thing is going on. So you have to know that there is somebody wanted to do something. Okay, so it's a commercial thing. So these companies, they used to have teams, people around the world, just taking information here and there. And then they're putting this information in I don't know, in Excel, in whatever things, and it's collapsing in some software. but it's really not automated at all. No, it's not automated in any way. Usually there's a lot of, I'm calling this guy that I know, and then I write here, contacted, whatever, there's something opportunity here, and then I call this other guy, and this kind of things. So this project is about automation of this structured information, and there's several sources of information here. As I told you, is that this public information, like you're going to build something that a government is paying, then usually there's a public platform with this information. So we take this information and you have it available in the software. There are news, that is non-structured information. There are social networks that people is talking a lot in there. And there are, I don't know, international entities that pay for, I don't know, for purifying water in the middle of Peru. And these are projects that are coming from another, it's a kind of public, but it's not a state, it's an international thing. And there is private information. Say, these companies are usually paying for information that other companies are providing because this is certified information. An example, in South America, for example, there's a company called BN Americas, and they sell these kind of things. They sell you information about construction, about whatever. They're coming from news, but they send people into the field to really check that this certified the information. So you pay for information, and it's usually pretty expensive. It could be like a 60,000, 80,000 per year easily. So it's just I don't know, an RSS of news and stuff and things, but with the extra check of there's some human behind just checking that the information is right. So there's a lot of flow of information in here because it's really valuable, because you want to really be aware of some opportunity before your competitors. So what we do is collapse all this information, automatize all this recopilation of information, and we scan for really early hints of construction things. And how we do that? We do that with social networks, actually on Twitter. During the pilot, in the pilot project, in the first 3 weeks, we discovered two. One construction thing in Australia, another one in Panama, that nobody was aware, and it was because politicians were speaking in Twitter, because people like to talk, and when you are a politician, you want to be, into the middle of the discussion. So people usually talk too much in the social networks. This is one of the business in here, like a catch information around in an automated way, obviously, because if not, it's impossible to really be the first one having this information in hand. Okay, and this is just an example of one of the things we do. So now, changing gears a little bit. So about neural nets and all this universe, I call this the business multiverse because it's really a total different universe if you are a tech company or you are a guy producing ham, like Alvaro said before, or whatever. And why? Well, because your approach to the technology, to what you do, it's really different, right? So it's really important who you are to see how you apply machine learning to your business. Why? Because you're a tech company. Say a tech company could be, I don't know, Google, Facebook, or whatever. All these things are your core business. I mean, your company is constructed around data and selling data and capturing data from your Android things, and everything is in there. So your business is that. So it makes sense that you have a development, and that's why you have PyTorch and TensorFlow, because it's your business. And if you work in there, actually, it's not a huge difference between research and working at the TensorFlow product, for example. But this is just a small part of the business, right? Like then you could be a provider, a consultant, a little bit like Triple Alpha or Ultra Protect, or big ones. Then you could be a technology user, that if you have an IT, you can do your own developments. If not, you hire a consultant. So it's the guy that hire us, you're a technology user. Then you have technology dreamers that and this is my own vision of the thing, and I don't take that like, I don't know, that's like extensive summary of what is the situation. This is what came to my mind. Technology driven is what I call somebody they want to do something, but they don't know how, and they don't know even how to call a consultant, or they're really, turning around. I would like to do something, but they don't know how to really make it happen. And then you have, and this is happening, people that the answer is, what are you talking about? Where is a computer? Where's data? What are you talking about? I'm doing a lot of money doing this thing. I'm doing this since the 60s. I don't freaking care. So, and this is happening a lot as well. So this is, you see, this is if you are developing PyTorch, or you are working like a cutting stuff. All of this is industry business, but it's nothing to do. I mean, that you are in a different universe here, from one side to the other. So I'm trying to really go through the talk in this 3 small cases that summarizes this kind of guy. So the second thing is data. I told you before, right? You are in Google thing, your data is around. You have data everywhere. And data is not about quantity, it's also about which kind of data you have. So in energy physics, you have data, precision data from detectors. It could be clean or not, but actually super clean, you compare it with other things. But more than the cleanness of the data, you're measuring physical quantities. What that means, that the relationship, somehow it's laws of nature. You are measuring, the momentum and the mass. There's nothing weird in between them. I mean, you know what is going on. But in real life, you have first, the quality of data is whatever you have available. You have data from machines, we saw before in previous talk. Sometimes it's, clean, sometimes it's not, sometimes it's in format whatever. But but at some point, this data from machines, you're measuring as well physical quantities. It's like a temperature, it's pressure, is whatever. But then you have human data that is really a mixture of qualitative and quantitative, and it's not really clear. An example, we have this product that I told you before, that I call Alta tender. It's basically analytics on the public tender. Public tender is any contract that a government is putting in the out for constructing or doing whatever. So from the, I don't know, the gas you need for a hospital, to the construction of a bridge, to the whatever. So everything that the public institutions, from small ones to the department of whatever, the ministry of whatever, everything is put in a tender, in a public way. And we do the software that you can analyze what's going on. You have alerts, you have some smart things, and you can really plot and analyze what's going on with historical data. Okay, so one of the things you want is, and I'm going to talk a little bit before, is the price you have to do. No, there's a contract. I say 1 million euros to do this, and then companies arise and say, okay, I do that in 900,000, and another one comes like, I do that in 850,000, and this you do it. And then you win or you lose. That's it. So you want to predict, you want a forecast of this price beforehand. Okay, this is something you can do. Actually, we're working on that with a neural net, in forecasting the prices of public contracts. Okay, that's a cool thing to do. But then this human data, what I mean by human data, this not pressure and temperatures. In some particular market, some company sometimes is losing money in purpose because they want to stop other companies to enter their market. So this is a totally, disruption thing. Like, the prediction is going one direction, and then at some point, because there's human intervention, it's boom. I cannot predict this anymore. My forecast is gone. And why? Because there's human with interests that are not, again, there's no temperature flow or pressure flow. It's like it's okay, now it was like that, and now I'm changing the behavior in purpose. So, and this applies to every, you work in retail, you have to really guess what people is doing. So this human behavior here, and it's not that it's dirty data, it's this kind of qualitative. It's really in a fuzzy, you're working in a fuzzy way here. And as I'm writing here, you are using this thing in a kind of qualitative way. So the next thing is like well, what are you doing with this data? Okay, so in a very summarized way, in a high energy physics, you can do two things, right? Like you can do precision measurements and searches. Okay, and in precision measurements, you can work on something and like, okay, I measured the mass of the top quark. Okay, and then you came 5 years after, say, I'm measuring the mass of the top quark, and which is the mass? Spot on, same. And why you're publishing that? Because I reduced the uncertainties by half. Okay, cool. Is this interesting? Yes, super interesting. Okay, this is a clear example that it makes no sense at all in business and in industry. So nobody gonna pay for having the same number with less uncertainties because they don't even know what uncertainty means. It's not something you can offer to a client like, okay, we're measuring this, we do a prediction, and this you have less uncertainty. Like, what are you talking about? No, this is something is not even on the table. So, fine tuning, better results, uncertainties, and doing this better and better. That is the way in science. It's not the way you do it in business. I mean, in business, like if you have nothing, give me something. If I have this something, I'm gonna pay only if I get something else. I mean, it's not like okay, you do it better. I mean, it doesn't matter. I mean, if you have a number, it's good. If you are selling me that you do the same number and you spend half on a year to reduce an uncertainty, and I'm not buying that. So here, the change of money is like you need to see the business as you do developments that are turning into profits. If not, you're out. I mean, it makes no sense. So if the guy that is paying for it not seeing what you are doing, you are out. It's impossible. So summary of this part. So the summary of this part is that the problems you're trying to solve depend on who you are. As I said before, it's really, really different if you are Google or you are, I don't know, a guy selling whatever. And the ability to solve these problems with AI, it ranges, again, from state-of-the-art technology, like, okay, I'm developing TensorFlow, or, and it's real, what do you mean by computer? Like you go to production lines and then you say, where do you store the data from the PLCs? You're monitoring the data, yeah. And where do you store it? Where is your server? What are you talking about? Nobody's storing anything. So this data is just gone. I mean, that you have real data, you monitor things, and then it's overwritten somewhere. I mean, nobody takes care of that. So in any case, I mean, everything relates to the conversion of this technology into benefits, right? So the focus here is not doing better, is doing, I mean, how it impacts my business. If there's not an impact, and usually this impact means money, there's no problem and there's nothing to solve because nobody's going to pay for it. Okay, so case one. The case one is the one that, okay, tech company. I'm not going to go here in detail because I'm not the guy telling you how Google or Amazon or Facebook works because I never worked there. But as we talked about this before, technology and data and computing services are the core business. And sometimes it's even hard to see which are these business. I mean, which is the business at Google? They're doing services, yes. They're doing this Android developments and things. They collect data, they sell data, they do AdWords, they pay for marketing. So they position their search thing. So where's the business there? There's a lot of business that is a mixture of things. So they basically the neural net, the AI fits everywhere. So it's actually what I'm saying here. So in the next slide. So the use of these kind of things in this kind of companies is everywhere because they are constructed around this data. They are constructed to collect and sell this data. So there are many places to optimize. There are many places to do this kind of things. And then this is the case of that Amazon, for example, is like where's the business? So are they a retail company? As we discussed in the previous talk, actually they are doing money with the service with AWS, with the service selling stuff. So and it's at that point that they're making more money with AWS than with the retail thing. Actually, they are losing money with the retail thing in outside US. So then, what is Amazon? It's a retail company or it's a service provider company? Well, I think it's both and most than that. I mean, it's really hard to keep track of what's going on here. So bottom line, I'm not gonna go into the cases in there because I have no idea. So that's the bottom line. So case 2. So we're going from Champions League to to another leagues. So case 2 is industry and manufacturing. Okay. And then at least, even if it's not clean, machines usually they have data. And the first thing you want to do when you have data is, and most of the times it's already a huge improvement, is monitoring. If you can put this data in a nice way and you can see what's going on, you did something already. And usually the client is more than happy to do that. Then if the guy is more advanced, the things you can do is just, well, let's optimize something and of the process. So you read the data around the production line, and you have velocities, you have pressures, you have temperatures, you have whatever the process is, and you can optimize this whole thing sometimes. And we did some works on that sense with predictions, with time series of one of these processes in the boot market and in the particle board and MDF. And we use some neural nets in this sense to really optimize the process. Then you can do nice things like predictive maintenance. And then in a manufacturing thing, you can do that, but it is really critical when you have equipment that is not accessible. When you are operating something that is far from where you are, having a predictive maintenance is really cool. What that means usually is, I mean, the basic thing is just monitoring vibration. So if you have something, if you have an engine, it's something that's turning, it's turning all the time in the same frequency, so you have a behavior. If these things start to change, this is a hint that something is going on, something bad usually. Same with temperature, oil temperature. So something is really, you know, there's friction somewhere, and then you have temperatures from oils and stuff. Then you can mixture these two things, correlate vibration and temperatures, and then you have a hint that something is going on, and it's a good time to really go into there and see, okay, well, before it crashes. As I said, we have some projects to do this in wind power plants, so like a, you know that these wind things, energy production is, they're in a remote places most of the times, really high, or by the sea, and then the guy that's operating that is not really there. So it's really critical to have this kind of predictive things. It's usual actually in oil extraction plants in the middle of the sea, where if something is kind of breaking, you need to bring the equipment by a helicopter usually. So this is a really interesting place to really monitor and have predictions of what's going on, because as you can imagine, these kind of things, the point is not stopping. To whatever you do, you don't stop. Stopping is losing money, so you have to stop, and if you have to bring the piece of material in a helicopter or whatever, it takes sometimes days, sometimes weeks. So it's something you really want to do. You want to have alerts beforehand. And when you monitor, you optimize, you have data, you have real data, and you have past data, and you have all of this, and you have a kind of say a formula that defines what your process. You can have a digital twin that is actually everything together, right? It's like you have data from the whole process, you have a kind of a model of what's going on, and then you can do some simulations in there, because you can take this part out and see what's going on. But why you cannot do that in stop things in high energy physics? You can do tests and you can do stuff, but in actually manufacturing things, you don't want to stop, because again, if you stop, you're losing money. So nobody gonna do tests or simulations or whatever. So these digital twins are cool because you can do this digital simulation of what's going on if you change this on that, because you don't have the ability to do it in real life. And more on digital twins now is really trendy, this kind of digital twins in warships. I'm saying that because we are here in Ferrol, and we're the guys in front of me, I'm living by the port, so the guys in front of me are doing these warships right in 200 meters from here. And one of the trending things, like they're gonna do a digital twin of the boat and whatever. Okay, this is somehow science fiction, because it's okay. It's really cool, like an idea, but then what do you do for real is not really okay. It's not that like a digital twin of the of the boat. You're gonna have some systems. You're gonna have some stuff that are gonna be controlled from remote. This is another case of the digital twin. It's cool because you can operate from remote. But okay, there's a lot of marketing around these digital twins as well. So you have data, you can do some things, and another things is just okay. It's just a little bit of marketing. So use cases. And as I said, I'm not going through how many layers or things or how is the architecture of these neural nets. But some things we did actually is some regressions, because you want and time series LSTMs. Why? Because you want forecasting. Forecasting is always cool in business because okay, you predict stuff and you have what's going on ahead. So we did as well some forecasting for marketplaces, like a prediction of silicon prices around the world for a company. And forecasting, I say, is one of the big cases where any client want to have it, because it's okay. It's going ahead and trying to figure out what's going on. In this case, it's not forecasting of prices, forecasting of the production line. Like we really define before has set points for the production line, having data from historical for previous days. And as I said before, another thing is the predictive maintenance that is usually really related to vibrations and temperatures and these kind of things. And this kind of thing you can do it as well with LSTM. So the vibration analysis, you have something that is really clean in sinusoidal things, and then when it's going outside of this when your prediction is going outside of this behavior, is really a hint of that something is going on. And whoa, this went crazy. And the case 3 is like it's us, right? It's like what I do as a provider, where can I apply neural nets if I'm a consultant or a technology provider? Okay, and I commented already these kind of things a little bit. It's like it's a little bit different if you are doing custom-made projects, because then you develop something and you go home, or you have your own products. When you have your own products, and there are companies they only sell their own products. So there you are in a continuous development. So somehow you can have a continuous search of where you fit your development with neural nets or AI or whatever. But in general, all these consultant companies and consultancy is an open field for applying AI, right? So the only thing you have to do is define the right problem and see how it fits here and there. So we talked a little bit about business intelligence before, and I summarized that like helping others to make decisions, right? And based on, we talked about that before, based on your own data and external data that you pay or not, and public data. At the end here, again, things that are always working is analytics. That is, you don't need really AI for many of these things, and forecast. And these kind of things are always working because you give information that is valuable based on previous data to make decisions in the future. So some cases, before going in our cases in Archaprotec, I asked around and I asked some friends, all of them they're ex-energy physics. And I don't give you the name of the companies, but if you, the first one is if you put in Google social impact of investment portfolios, you're gonna find the company. So these guys are trying to do. They have a product that is for markets that are in the Nasdaq, they are in whatever market. They are trying to have an impact of the investment in social. So like how socially this investment affects. And this is a product by itself. So there's a lot of things. And one of my friends told me, okay, we do found classification, we do news classification, a little bit of we do with this construction thing. We try to do outlier classification, and they tested neural nets everywhere. And at the end, they implemented decision trees everywhere. Why? The answer, I'm not expert on that. The answer was due to performance and more than that, instability. Why is that? Because sometimes when the neural net goes deep and you have deep learning, the architecture is really a pain in the ass. And having stability for this architecture sometimes is complicated. So usually you go more stable with a decision tree, with a random forest or whatever, or this kind of even deep decision tree. Then I have a friend that is doing financial crime detection. And I asked, okay, I'm sure you have neural nets all around. Like, not at all. Not the first one. There are companies saying that they're doing deep learning, whatever, for this final crime thing. It's at the end, it's detecting outliers, and in my experience, hard to believe. So this is an example of where you think, okay, wow, it would be cool to have some neural net here. But if you have something that is not a neural net, that is more clean, that is less sophisticated, but it works, you go for it. I mean, in here, stability and something, things that work are much better than fancy things. And then you have people doing geolocalization for retail. It is taking market insights, and this is one of the examples where plenty of data, right? Like these companies is kind of, and here they have neural nets. I don't know really where, but this is predicting what the client is doing when it's buying in there, or is good to open a store in here because in the next door there's another store and that relates to your business, and this is good, or is good to open your store 200 meters in the same street. This kind of analysis is one of the things you do for retail when you offer this geolocalization things, like, okay, it's good to do this here and not here, and because of this and that, and this analytics, and most of the things are analytics. But okay, in the kind of predictions you can use neural nets. And this, again, this is just, I asked this week to people I know just to tell me, okay, do you use neural nets? And the answer, most of them was no, we're not using neural nets. Okay. So where we use neural nets? This is, I told you before, this is our product, and it's analytics and decision-making in public tender. So in Spain and in Europe in general, and in most of the countries, every contract coming from a public organization is public. And companies go there and bid for it. So what we offer? We offer the analytics of historical data. We offer the real data that is suitable to your profile. And we offer some forecast of the price you have to put to this contract. Right now, we're just offering an average that is with more influence of the dates that are close to today. So it's a weighted average, because what was happening in 2012, you really don't care right now. But what was happening last month, yes, you care a lot. So it's just an average, and it's just an estimation. Nobody in the market is offering even an average. We are the first ones offering a price forecast, and now we are working in something that is really really close to finishing. Probably in the next version of the update of the software, we're going to have a neural net that is doing a forecast. And is Adrian was one of my colleagues, was attending the course last week, and he's the one doing this neural net. And basically, the neural net is basically predicting the price and the number of offers that you need, because you don't act exactly the same if you know that they're going to be 3 offers or 15 offers. So usually the offer with, so it's a bit tricky because it's not always like that, but the offer that is the lower, it wins. But sometimes they call that how do you call that in Spanish? Baja temeraria. So like a temerity thing, like a I don't know how to say it in English. It's like you are doing an offer that is too aggressive, too low, and it's outside of the market, and then you are out. So you have to play off going down, but not too low, because then you're out. So it's a tricky thing, and this prediction is really important because like you can go in or out of the contract because of this. It's basically one of the big decisions you have to make when you put an offer on this kind of contract. And this is a place where we have neural nets. And then, so to finalize a little bit here is like where else you have neural nets and which are the places that are trendy now for offering AI. And when I say what is trendy in AI now, I'm not talking about developments of state of the art. I'm talking in my experience about market, about clients, what people is asking for. And to us, people is asking more and more stuff related to natural language processing. And why? Because people are seeing more and more applications of this thing, and makes totally sense because, as I'm writing here, we are humans. And there's a lot of information, in particular in the business intelligence thing, that it's written or that you do with bots or chatbots or stuff. So there's a lot of information that is human communication. So you want to somehow automatize the information extraction of these kind of things. So you want to clusterize documents. You want to see, okay, what is this about? You want to see labeling. I mean, labeling is super easy to do. And I have an example. Somebody contacted us at some point. It's like saying, okay, wherever a company that we label the type of what was that? Was related to food. Like, okay, is this canned food? Is this a brick thing? Is this I don't know? Is this fish? Is this pork? And there's somebody labeling news related to that by hand. So and somebody gonna say, okay, if these people is on vacation or sick, there's no labeling. There's no labeling at all in 2020. I mean, like labeling a text, just not extracting insights of the information, but just labeling, saying this is talking about whatever. You have packages that are already constructed, and it's like, I mean, it's 10 minutes to do that. So people is getting more and more in this extraction of information, and makes totally sense because there is all around a lot of PDFs, a lot of this is the market behavior, this is whatever, but everything is brilliant. So to extract this information most of the time, and in particular to extract historical information, you need to go and process these PDFs and information. So really, from this year, I really saw that clients are going like crazy in this kind of developments. People is asking more and more, oh, can you do that for us? And this kind of thing. So, and in terms of neural net, there's a lot of stuff in there. Like the first thing you want to do when you want to extract information for a text is what we call vectorize that, right? Like you have to put into numbers. You have to put these words in context and in numbers. So one tool you can use is a Google Word2Vec. But there's something now that is not a neural net that's called BERT that is really trendy as well from Google. And then you have clustering techniques, because one is vectorized. You want to see, okay, where are the topics in this document, or labeling things, and behind that there are always neural nets. So there's a lot of applications of neural nets in there. And then, I mean, I bring me to the end of the talk. It was a kind of a summary of what I think is the status of the usage of neural nets. And as I said from the beginning, the use of neural net depends on who you are, strongly, and which is your core business. And I think it's pretty clear that this is the case. It also depends on how the effort translates into money, and how you translate this to profit, because otherwise, if you cannot show to a client that you can translate this into profit, there's no case. So you cannot use this AI anywhere. And we are using neural nets, but when I'm talking to friends, everybody telling me they are not using at all. So I just say here is one of the techniques. There are much more. So you shouldn't be stuck to this particular one, and whatever is doing better, okay, let's go for it. And that's it. And thank you for listening.
Thanks a lot, Miguel. Yeah, I think this complements very nicely what Álvaro presented before. So, question from Miguel?
You comment, Miguel, that companies are not too much interested in uncertainties. No, when you make when you present them a proposal, but uncertainties implies that you have a better prediction. No, I think it should be possible to teach them or to let them understand that uncertainties are important.
In principle, yes. Then reality, I mean, you can do that, and definitely part of our work is to teach not only uncertainties, everything. But the problem is the people you have in front of you is not always understanding this terminology, or even what uncertainty means. Just talking that. I mean, in most of the cases, it's not like you can explain that it's better. Like, what are you talking about? I don't want to talk in these terms. I mean, give me a number and shut up. This is the summary sometimes of the problem. So yeah, depends on the company, depends on who you have in front of you, and it's not always the case. But in big companies, for example, there's a problem. This is really interesting how they propagate information and stuff. Most of the companies now, because it's really cool, they have an innovation department. And in principle, you can talk to people in there in the innovation department, because they do some kind of courses and stuff and data managing and whatever, and they understand these kind of things. But in most of the cases, this innovation department is not propagating into the business departments, because the big companies are really complicated, because they are, you have your part of the business, your power there, and then it's coming some guy that's from a new department and it's from innovation and it's telling me what I have to do, and I want to do this. I'm going to do exactly the opposite, because it's coming from somebody who you are. So it's really, I mean, it makes sense. You should go in this direction, but real life tells you that it's not that easy to really do this teaching and this flow of things. But yeah, in principle, you can teach them. Yeah, that for sure, because it's really crucial thing.
Yeah, I have the same question actually. That it surprised me a bit. Yeah, I mean, it's true that we need. I guess you need an extra layer of pedagogy or pedagogical explanation whenever you have to deal with people who have no background in mathematics or in science in general, because of these kind of things. But I mean, at the end, I think, as you said, it can be translated into money. The problem is explaining to that.
Yeah, sure. I mean, sometimes it's not even mathematical or education; it's just sociological. So in manufacturing, I don't know what the guys on Triple Alpha said of that, but sometimes, I mean, the fact that you're entering in a production line with a computer, people start to freak out, because people is saying, you cannot talk to the guy anymore, because people is saying, there's a computer, I'm fired. So, and with this, with this presentation, it's really hard to talk to the people. So, people don't want to talk to you, because they are extrapolating the thing that if you bring some automatization of the things, then the guy is out. So it's more sociological than another thing. It's complicated because it's your salary, is your thing. So it's not like the problem. Like you extrapolate this problem is I'm not having a job anymore. So it's delicate. Yeah, it's not. Not that
I completely agree. The problem, the sociological problem in industry, in manufacturing is huge. It's amazing. And if you want to talk with, for example, maintenance, for example, well, there can be any other department. First, you have to talk maybe 10 minutes or 15 about football, about any other stuff, and then you can start talking about your stuff. But if you enter in a place with a laptop and go directly to the topic, you are going to have problems. And with uncertainty, yes, you are completely right. Again, I agree completely. We try to teach some of our clients about that, and about that measurement that they want to see was not very accurate, so it doesn't provide information, and well, they didn't understand. So finally, they are seeing these values, these measurements.
Yeah, but again, it's I think the problem is that, again, as providers or clients, there's a universe in there. So there are people they understand and they have a very defined problem, a really technological problem, and there are people that are in the 19th century. As easy as that.
Don't you think this is like, this is maybe not too politically correct to say, but don't you think this is correlated to what, to being in Galicia or in Spain in general?
Not really. I mean, yeah, there's a component on that. For example, but there's outliers. I mean, if you compare with Switzerland, yeah, but there's a different world. So Switzerland is not representative of anything in the world, right? So then you compare to that, yes. But if you compare of what's going on around the world, we don't have to be European center, be in America, and they sell these kind of things. They sell you, and why? These or companies. The problem is that if you are making money in a way, changing nothing for decades, and you're still making money, nobody gonna change it. You don't want to change. That's the thing, because I mean you don't care. So you know. Real life. I talked to a guy, say like, I'm making more money than ever. The machines were from the 60s, literally from the 60s. So how do you convince that the guy that, you know, like that's doing business of million euros, that change the whole thing and do whatever? Like, I don't care. I don't really care. So when something breaks, then when we talk, but this going ahead and thinking ahead and this kind of things is, you know, it's complicated. It's complicated. And it's not specific from here. I mean, probably here we have a really particular thing, but it's not really that, you know, it's not like we are weird in this sense. I think it's more or less the same all around. Again, if you don't compare with very specific places, like, I don't know, Denmark and Switzerland or whatever.
Okay. More questions, comments? Okay, if not, I think this is a good moment to close the session and the course. So thanks a lot again to Miguel and Alvaro for being here today. I think this was very useful and a very nice complement to the rest of the course. Hopefully in the future, as Miguel said, we'll have the chance to meet in person and have more interactive discussions. So yeah, thanks everyone for being in the course. I hope you enjoyed, and yeah, we'll keep in touch. The Indico page will be open. You have the chance to look at the slides and everything that was presented over there, and also we are recording all the sessions and we are posting them in YouTube. So the IGFAE has a YouTube channel. So in case you want to go through any of the material presented again, you can just watch everything in YouTube. Okay, so thanks everyone. Bye-bye.
Bye. Thank you.
Thanks a lot.
Thank you all.
Bye.
Bye.